the geomorphic characteristics of aeolian processes, there are two principal processes involved. They are deflation and abration. And deflation means to remove matter from an environment. So think of the case where you have blown up a balloon and then you let the air out. You are deflating it. You are reducing the aerial extent, the surface area of that balloon to a smaller volume. This same process happens in deflation locations. We're removing the smallest particles from this environment by wind action and transporting them somewhere else. All right, that's deflation. What it produces is something called desert pavement. It leaves behind the bigger structures, the bigger clastic pieces that are too large to be picked up by wind and therefore cannot be transported. When there is water in this environment, the water is also relatively less capable of moving these larger pieces to another environment. What ultimately this does is it acts as a shield from removing any other small particle material which could be in place but underneath the larger particles as a result. Blowout areas can be quite large in size. Northern Sahara has a number of them. A significantly large one is Qatar Depression in Egypt. The Qatar Depression is responsible for much of the active sand dunes in northern Egypt. What has happened is this depression bowl is the source area for the desert dunes that we sort of imagine when we think of desert environments in Africa. Desert pavement looks like this when you look at it up close. So for scale, we have this fella's hand here, and the fingernail is a good comparison to size. So we're looking at pieces as large or larger than this individual's fingernail, and they can get certainly quite substantial in size, as you can see here. So from this image, initially we saw a pretty turbaic condition of large and small pieces mixed throughout the composition of this structure. Over time, the small pieces were removed off the top. As you continue to remove the smallest pieces, the ratio between large pieces to small pieces starts to diminish. We get a lot more large pieces, removing the volume of small pieces available. Ultimately, what happens is all of those small pieces that can be mechanically moved by the wind are no longer available. They are housed underneath this shielded environment, which is the desert pavement. It's a deflation bowl because what we see is we've deflated, we've removed the total volume in size of this area. And again, a deflation bowl can be hundreds and hundreds of miles across. It can be tens of miles across. It could be a mile, a quarter mile across. Generally, they look like a concave bowl, sort of like a very flat spaghetti bowl, if you will.